It's the thermal conductivity test. The term thermal relates to energy transferred as heat, so we'll be heating things up. To test thermal conductivity, we'll need a household lamp fitted with an incandescent bulb. Aside from giving out light, the light bulb also gives off heat when it's switched on. We'll use this to warm up our objects and test whether the materials in the evidence bags are good or poor thermal conductors. We'll know this by feeling the materials. They'll get warmer if they conduct the heat coming from the bulb. To make this a fair test, we need to hold the objects under the lamp from the same distance away. So I'm going to use this beaker. We also need to hold the objects under the lamp for the same amount of time. Now, one more thing. We need to make sure that we don't touch the bulb because it can get very hot if it's left on for too long. Let's start with evidence bag A. Do you think this will be a good conductor? This material stayed cool, so it's a poor thermal conductor. Let's try evidence bag B. Will this one get warm? This is getting quite warm, so this must be a good thermal conductor. I wonder what will happen this time. This stayed pretty cool, so it's not a good conductor. Now for evidence bag D. Now this looks like it has both plastic and metal parts in it. It's warmed up a little, so this must be a thermal conductor. Finally, evidence bag E. Let's put this under the light bulb. Moment of truth. It hasn't gotten warm, so this is a poor thermal conductor. Let's write it down. Very illuminating. Thanks for your help, Professor Lightbulb. So, even though we can't see the energy being transferred to the object by heating, we can feel it, so we can tell which materials are good thermal conductors. And that evidence will help us get one step closer to cracking the case of missing Peppy. Peppy?